Welcome to the geometry video for skill number 82. I can find the measure of an inscribed angle and use this to solve problems. We'll start our notes on page 82A, and what we have here is we have a circle, and inscribed inside the circle is an inscribed angle, and it's important that the point E occurs on the circle. The arc trapped within the angle is called the intercepted arc, or you could say that arc DF subtends angle DEF. And what we know about inscribed angles is that the measure of the angle is actually half the measure of the arc. So if our arc here was 70 degrees, then our angle would be half of that, which would be 35 degrees. Interestingly enough, if we draw another angle in here that also spans that arc DF, then we're able to say that that angle is also 35 degrees. So as long as our points D and F haven't moved, E can be anywhere else on the circle, and we would get angle 70 degrees. Or rather, anywhere on this half of the circle. Let's see how that plays out in example. So, example 1, we are told that the measure of arc AC is 100 degrees, and we need to find the measure of ABC. So, the angle ABC should be half of the 100 degrees. So we find that that is 50 degrees. In the second example, we start with the angle that's given, which is 90 degrees, and we have to find the measure of the arc. And we find that if we are given 90 degrees for the angle, then the arc is 180 degrees. This observation allows us to make the following statement. An inscribed angle subtends a semicircle if and only if the angle is a right angle. So if this angle is a right angle, it's going to subtend a semicircle, which makes sense. A circle is 360 degrees. A semicircle would be 180 degrees. So the inscribed angle that captures 180 degrees would be a 90-degree angle. One other piece of this lesson is that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So in the circle drawn to the left here, I have put a quadrilateral inside of it, and the opposite angles, A and C, must be supplementary. Remember, supplementary means adds up to 180 degrees. So we see that in the example below. Example 2, we've been given a quadrilateral, and we see that the quadrilateral is inscribed inside of a circle, and so we need to find the measure of each angle. And I could say that D and B are supplementary, or A and C are supplementary. And I went with the route of A and C. So the measure of angle A plus the measure of angle C should equal 180 degrees. So we find 5x plus 5, 4x minus 5, and we do the algebraic work and arrive at x equals 20. Once we know x is 20, we can plug 20 in for each angle. 5 times 20 plus 5 is 105 degrees. 6 times 20 minus 8 is 120 minus 8, which is 112 degrees. 4 times 20 minus 5 is 80 minus 5, which is 75 degrees. And then we do the final one, and we find 3 times 20 plus 8 is 68. And we can check our work, and we notice that 105 and 75 are supplementary, and 112 and 68 are supplementary. We could also notice that all four angles add up to 360 degrees, which is an excellent way to check to make sure that we did this problem right. Alright, ultimately this scale boils down to two things. The first is if we have a circle with an inscribed angle, then our arc that subtends that angle, if it is 120 degrees, we know that the inscribed angle is half of that, which would be 60 degrees. The second piece of the lesson was regarding circles. If you have a quadrilateral drawn inside of it, then angle A plus angle B, the measure of angle A plus the measure of angle B, they are supplementary, so they add up to 180 degrees. Likewise, C and D are supplementary. All right, that concludes the lesson. Thank you.